IOE 413 Nonlinear Programming Study Guide. This problem is about the set K, which is the set of all x such that ax equals b and x is non-negative. And we assume that K is non-empty, so there's at least one point in the set K. So this question asks, is K convex, and why? This is not the set K. This is just some example that I created in 2 dimensions. And it's here to review the definition of a convex set graphically. So let's have 2 points, 2 arbitrarily chosen points, P and Q. And then make a line segment joining P and Q. And we can represent the segment parametrically as lambda P plus 1 minus lambda Q, and lambda is between 1 and 0. So if lambda is equal to 1, you're at P. If lambda is equal to 0, you're at Q. Lambda 1/2 would be in the middle, and so as lambda goes from 1 to 0, it traverses along this line. So this parametrically describes the line between P and Q. Now, a convex set is one in which, for any P and Q in the set, the line between them lies entirely within the set. So the way to describe that line entirely is with this parameterization. That's what we will use for this problem. So what we will need to show is that for any P and Q in our set K, lambda P plus 1 minus lambda Q is also in K for all lambda between 0 and 1. So let's consider these points P and Q that are in K. So let's start with point P is in K. What that means is that A, P equals B, and P is non-negative. Over here, say Q is in K, and that means that A, Q equals B, and Q is non-negative. And remember that we're going to work with lambda in the closed interval 0, 1. So lambda is between 0 and 1, including the endpoint 0, 1. So let us multiply this statement that P is in Q here by lambda. So what we get on both sides, so we get is lambda AP is equal to lambda B, and lambda P. Now remember, lambda is between 0 and 1. It can't take on negative value. So when you multiply both sides here by something that is not negative, it's 0 or positive, you keep this inequality sign going the same direction. And that just reduces down to, you don't need the lambda times 0. You have lambda P is greater than or equal to 0. Now over here, let us multiply by 1 minus lambda on both sides. So you got 1 minus lambda times A Q equals 1 minus lambda B, and then we'll do 1 minus lambda Q on the left side, and on the right side we have 1 minus lambda times 0. But lambda is between 0 and 1. And therefore, 1 minus lambda is somewhere, it's 0 or positive. Can't take on a negative value. Can't take on a negative value because lambda can't be larger than 1. It's on the closed interval 0, 1. So that means we keep our inequality going this direction. And again, the right-hand side is just 0. And the left-hand side is 1 minus lambda q. And what I'm going to do on the next slide is I'm going to add these two things together and show you these two lines here. Add them together to get an equation that we will show satisfies the requirement of the point lying on the line between P and Q, parameterized by lambda, will be in the set K. And we'll look at these to get a similar non-negativity requirement. So the first thing we're going to do is add together the two equations, lambda AP equals lambda B, and 1 minus lambda AQ is equal to 1 minus lambda B. I'm going to add those two together to get an equality. And we will show that this satisfies the requirement that an arbitrary point on the line segment between P and Q lies within K. So let's start with lambda A P plus 1 minus lambda AQ is equal to lambda B plus 1 minus lambda B. Now let's rearrange this a little bit so we get A times lambda P plus 1 minus lambda Q. And that's just basically collecting the A's together outside and front. And that's equal to, now you'll notice here is we have lambda B plus B minus lambda B. The lambda B and the negative lambda B cancel out, so we just have B on the right-hand side. So this point on the line segment between P and Q, which is lambda P plus 1 minus lambda Q, this says that it satisfies, that point satisfies the requirement A times the point is equal to B. That was the first part of what's required to be in K. Now, the second part is that this point be non-negative. So you'll recall from that slide, lambda P is greater than or equal to 0. And 1 minus lambda Q is greater than or equal to 0. So now, if you take two things that are both greater than or equal to 0 and you add them together, you will get something that's greater than or equal to 0. So let's do that. Lambda P plus 1 minus lambda Q is greater than or equal to 0. These are the two conditions required for the point lambda P plus 1 minus lambda Q to be in the set K. And since this is true for any arbitrary P and Q in K, and any lambda on the closed interval 0, 1, K is convex.